Hello everyone, I'm Shangqi Lai from MONASH University. I'm pleased to present our work, OblivSketch, Network Measurement as a Cloud Service at NDSS. This paper is a collaboration work between my colleagues Xin Liang and Joseph from MONASH University, Xin from RMIT University, Xi from Tsinghua University, and Dongxi Surya from Data61. Network function virtualization allows enterprises to subscribe to third-party network functions designed by the service provider like IBM and Cisco to manage their internal network. In this context, network measurement is a core component of many important network functions. Particularly, we may use the flow size information for the traffic engineering and heavy hitters or heavy change flow for abnormal flow detection. To enable network measurement, CMSketch is widely adapted. It is a probabilistic data structure that can provide a precise estimation on the flow size. A CMSketch consists of the hash table and a set of hash functions that map the input to a row of the table. When inserting a flow, it will hash the flow into a specified position in each row and add 1 at those positions. The position will be repeated for each inserted flow. And when we query a flow, CMSketch hash the flow to each row again and retrieve the corresponding values at the hash position. Then returns the minimum value among those values as the size estimation. As we can see, CMSketch only needs a tiny memory space to keep the hash table, but it can still ensure high fidelity for arbitrary workload. To enable flow-based measurement tasks mentioned before, a flow list keep all flow IDs also needed. For example, to query heavy hitter, we will use all the flow ID to query the sketch to retrieve and short their flow size. Then the top K flow will be deemed as the heavy hitters. An enterprise can send its local network statistics to the cloud and employ the service on the cloud for measurement tasks. However, the security concern arises due to the sensitivity of flow statistics. There are several work show that the statistics can be used to learn private information or conduct attacks on the network. And there are some existing solutions based on secure mathematical computation, but they are inefficient and cannot meet the real-time requirement for measurement. An alternative solution is to use Intel SGX, which offers a trust execution environment called enclave. It can securely execute network functions and protect the privacy of the underlying network. SGX has been widely used to enable secure network functions such as IDS, load balance, and the firewall. Thus, we may consider that the following question: can we directly migrate existing network measurement services into SGX? Well, intuitively, we can deploy the list and the sketch within enclave, and then we use a statistic module which update the list and the sketch and execute the query within the enclave to avoid attack. But we also recognize the challenges in terms of the security and the efficiency of SGX applications, as well as the deployment of new service. In terms of the security, the adversary can collect information from the untrusted part of the server even if it's unable to access the enclave. And the memory access pattern is one of the most common side channel in this case. There's some recent work show that they can use the side channel attack with memory access pattern and infer the sensitive information protected by the enclave. Also, in the real-world network, the measurement service should be able to handle network flow in a million level. However, an enclave can only have 96 megabytes runtime memory, we call EPC. Consider our strawman approach. Since the sketch only in the gigabyte level, it can easily fit into the EPC. However, if we must keep a million flow ID within a flow list, this will exceed the EPC limit. As a result, it will cause 5 times extra delay since the server takes extra time to swap the required page from outside to EPC. We know that EPC now is increasing to the 256 megabytes in the next generation CPU, but this is still limited. So in this paper, we proposed OblivSketch, a network measurement service based on the SGX. So we combine SGX and the oblivious data structure and the algorithms to protect the flow statistic against adversary while performing efficient measurement tasks. And our service can also address the memory access side channels. We implement this service and integrate that with SDN. And our results show that it can respond to queries over an internet scale network in real time. In our service, both the enterprise and application will attest the enclave before start running the service. Then the switch start to send encrypted local statistics to the enclave periodically. So we call this the epoch. So enclave will maintain the aggregation view on the underlying network for an epoch. And when the application will send the encrypted query and will receive the encrypted result. So in this service, we assume that the enterprise network is trusted as it's protected by the strict policy set by the enterprise. And since the application is subscribed by the enterprise, so we also say assume they are trusted. On the other hand, the adversary can control the entire software stack, including operating system, the hardware except CPU, as well as the network communication in the cloud server. In this scenario, OblivSketch aims to achieve the obliviousness of tasks, which indicate adversary cannot learn network statistics and the measurement results from the memory access pattern. We use the path override to keep the list and the sketch to prevent the adversary from learning those patterns. Since the list cannot be fit into the enclave, we follow some existing work. We can follow some existing work to put that outside of the enclave and use the ORAN client within the enclave to access that. Nonetheless, there are some communication costs between the ORAN client and untrusted memory because the I/O and the cryptographic operations. Therefore, we consider how we eliminate these above two costs while achieve oblivioususness at the same time. The following two observations help us to achieve our goal. In specific, we find that the measurement task only require the ID of heavy flow. Moreover, the heavy flow actually they're rare in each epoch. Thus, we propose use the fixed size list, which call OblivSketch to keep the heavy flow ID and the size, while we use the sketch to keep the size of light flow only. So this will noticeably save the memory cost on the enclave, and we can put both the list and the sketch within the enclave. And we also design an oblivious ORAN client, since the client now is also on the server side, and we don't want the adversary to run side channel against that. Finally, we design an eviction mechanism for the oblivious bucket, so it will evict the flow that no longer be considered as a heavy from the bucket. So this will capture the dynamic of the network because the heavy flow may not present at the beginning of each epoch. So we now briefly introduce our oblivious data structure design. So for oblivious CMSketch, we recall that the CMSketch consists of a hash table as well as a hash function. In OCMSketch, we store the hash table within the ORAN tree, and we use the hash function set to indicate the position in the position map. So when we insert to update the hash table, the client will use the hash function set to find the corresponding leaf node, and will retrieve the entire path from the ORAN to the stash. Then the leaf node stored in the position map will randomize after each access, so the attacker cannot know the actual access pattern of the hash table. And since the client is now on the server side, we employ linear scan on the stash to avoid access pattern leakage from it. However, the original stash is unlimited size, so which make the linear scan inefficient. Hence, we substitute with fixed size stash with 105 blocks. So this will introduce a negligible false positive rate, but will improve the performance of our ORAN client. The oblivious bucket consists of multiple entries, and each entry will have several buckets to keep 3 tuples, indicate flow ID, size, and whether the bucket has been evicted or not. And each entry will also maintain an evasion counter, indicating whether the entry has a small flow to be evicted. We also store each entry within the ORAN to ensure the obliviousness of it. During the insertion time, so OBucket will first refer to the hash value of ID to retrieve an entry, and scan all the bucket in that entry and try to fit the flow into one bucket. At the end of the insertion, the evasion counter will be updated. Then the OBucket will run the evasion and output an evicted flow. So this evasion process will scan the entry again. It depending on the evasion counter size as well as the availability of bucket. The output can be a dummy flow, which the value will be 0, or will identical to the input flow, or can be a minimal flow among all the bucket in this entry. The query is very similar to the insertion. It will scan the entire entry and return the match flow, or if cannot find the match flow, it will return 0. So here is the full protocol of OblivSketch. For insertion, it will insert to the OBucket first, and then insert the output flow to the OCMSketch. For query, the query will query both data structure and refer to the flag to indicate whether we will get the final result as the hewy part size plus the light part size, or the hewy part size plus 0. So the above data structure, they are all protected by the ORAN and the SGX, and you achieve data-oblivious because the insertion or the query, they follow the same routine. The complexity of them, they're actually also the same because they perform the same path of memory access with the different access type to retrieve the result or to update the data structure. We implement the proposed design as a plugin service for the real-world network infrastructure. So on the cloud side, we design a demo to maintain the enclave and process the communication between the switch and the application. On the switch side, we design a monitor gadget deployed on each switch. So this will aggregate the local static and send to the cloud for each epoch. To facilitate the communication process, we design a secure memory channel. So in here, which is shared between the untrusted and trusted part in particular. So this one is allocated on the untrusted part, but we use a user check parameter so you can share with the enclave. To protect the data within those fields, we also design the secure gateway, which will maintain by the trusted part, but will pair with the secure memory channel. So we can encrypt and decrypt the message during the communication. Traditionally, the enclave requires the data marshalling when you pass data from untrusted part to the trusted part. And our design actually eliminates this context switch and of calling the enclave. It improves the performance without harming the security. So we integrate our design with SDN framework by modifying the virtual switch and utilizing the experimental field provided by the controller as well as the protocol. So we achieve it with 300 lines of modification on the SDN framework, and our implementation is published on GitHub. We evaluate our system on an SGX-enabled workstation, and we use 2 datasets from CADA Internet Trace, so which contain millions of flow. And we can see here, so we have CADA 2, which have 2 times more flow than CADA 1. And our result actually show that OblivSketch, they can answer a large number of queries per epoch. So it can answer at 300 to 50 million per epoch, depending on the query type. And it has an identical query delay for CADA 1 and CADA 2. Even CADA 2 has 2 times more flow than CADA 1. Which means it's highly scalable. And finally, it can achieve a comparable accuracy to the plaintext work under the same design philosophy. We refer to our audience to read our paper for the detail of our evaluation. To sum up, the proposed OblivSketch handle the measurement task obliviously and securely, and it can be easily integrated with the existing network framework, and it can handle a large-scale network. And that's all. Thank you.